I, which is 30 minutes. We're going to call this x. Okay, so the first one is f of x equals 30 minutes. That's our first probability density function. Our second one, which is independent of this one, is we're going to give it the y variable, and it's going to be 6 minutes, because that is how long it takes for one to put on a seat belt. Furthermore, because we remember from Calc 1 or Calc 2, the modeling times with exponential functions, we can use this information and bring it into our discussion. And so we can have our probability density function of x, which is how long we stand in line, in this case, our mean waiting time is going to equal 30 minutes, and therefore, we will have 1 over 30, because 30 to the negative 1 equals 1 over 30, times the exponential function of negative x over 30. Now we can do the same thing for our probability density function of y. In this case, our probability
it's for 4:30, just letting you know.
In this case, the mu, or our mean waiting time, is going to equal 6 minutes. So we will have 1 over 6 e to the negative y over 6. Now remember, the product of our two probability density functions equals our joint density function. So, with these two components of our modeling with exponential functions, we can have equals but we're looking for the probability that we're not going to stand in line for over 40 minutes. So, we can denote the probability as this. Probability equals x plus y less than 40 minutes. Now if I were to graph this, it would look like a triangular plane, quite like this. And we can call this region D. The hypotenuse has an equation of 40, x minus 40, y equals x minus 40. Let me rewrite that so it's clearer. Y equals x minus 40. So if we want to find the integral of this, we would take the double integral from 0 to 40, from 0 to x minus 40. And we can put this piece in here. And since we are integrating, this is a type 1 double integral here, over that general region, it's going to be dy dx. And when you integrate this out, this will give you the probability that you will stand in line for less than 40 minutes. And that is how you model, mathematically model, using these exponential functions with independent random variables. Thank you.